Overview of Earth's climate history. Earth's climate has evolved dramatically over 4.54 billion years, shaped by factors like solar luminosity, which has increased 30% since formation, atmospheric composition, plate tectonics, volcanism, biological activity, and orbital variations. Early conditions were hellish and hot, transitioning to a habitable world with glaciations, greenhouses, and ice ages. The Phanerozoic, last 541 million years, saw the most dynamic shifts, culminating in the current Anthropocene warming. In the distant future, increasing solar output will render Earth uninhabitable, leading to its destruction during the Sun's red giant phase. Below is a chronological summary by major geological eons and eras, with key temperature estimates, events, and drivers where data exists. Hadean Eon, 4.544.0 billion years ago. Earth formed as a molten protoplanet from solar nebula debris, bombarded by planetesimals during the late heavy bombardment, approximately 3.8 Ga. The surface was a global magma ocean with temperatures exceeding 2000 degrees Celsius initially, cooling rapidly via convection and radiation. Atmospheric pressure was extreme, 27 atm, dominated by water vapor, CO2, N2, and trace methane ammonia from outgassing and impacts. Surface temperatures hovered around 230 degrees Celsius, allowing liquid water oceans to form under high pressure despite the faint young sun, 70% of modern luminosity. Periodic impacts vaporized oceans, spiking temperatures to 500 degrees C temporarily. No life existed. Climate was driven by accretion heat and volcanism. By eon's end, a steam atmosphere condensed into a superocean, setting the stage for habitability. Archean Eon, 4.02.5 billion years ago. A warmer, reducing atmosphere, high CO2, CH4, low O2, created a strong greenhouse effect, countering the faint young sun. Global mean temperatures averaged 85 degrees Celsius, with shallow seas and continents emerging from crustal stabilization. Volcanism and hydrothermal vents dominated, fostering early microbial life, for example methanogens, around 3.5 Ga. Methane from life amplified warming. Around 2.7 Ga, the first supercontinent, Valbara, formed, but climate remained humid and storm-prone. Possible glaciations occurred approximately 2.9 Ga due to lower solar output, but evidence is sparse. Oxygen levels rose slightly from cyanobacterial photosynthesis, approximately 2.7 Ga, beginning atmospheric transformation. Proterozoic Eon, 2.50.54 billion years ago. This boring billion era saw oxygenation and extreme swings, with solar luminosity approximately 80–85% of today. Paleoproterozoic, 2.51.6 Ga. The Great Oxidation Event, approximately 242.1 Ga, spiked O2 from 1% to 10%, oxidizing methane and causing a cooling crisis. Huronian glaciation, approximately 242.1 Ga. Earth's longest ice age, possibly snowball conditions with global ice cover. Temperatures dropped below freezing equatorially. Recovery via CO2 buildup from volcanism warmed it again. Mesoproterozoic, 1.1.0 Ga. Boring billion stasis, stable, warm, approximately 20–30 degrees Celsius. Climate with low O2, minimal glaciations, and supercontinent Rodinia forming approximately 1.3 Ga. Nutrient-poor oceans, limited life. Neoproterozoic, 1.00.54 Ga. Dramatic snowball Earth episodes, Sturtian approximately 720–660 Ma, and Marinoan approximately 650–635 Ma, glaciations, with equatorial ice and global temperatures, -50 degrees Celsius triggered by Rodinia's position reducing weathering CO2 drawdown. Ends via volcanic CO2 accumulation, leading to hothouse recovery and Ediacaran biota. Post-glacial cap carbonates indicate rapid warming to 30 degrees Celsius. Phanerozoic Eon, 541 million years ago present. Visible life exploded, climates cycled between icehouse, cool polar ice, and greenhouse, warm ice-free poles states driven by CO2, tectonics, and Milankovitch cycles. Era period. Key climate features of VG global temp. Estimate major events drivers Paleozoic, 541–252 Ma. Early warm greenhouse, late icehouse, 1722 degrees Celsius. Ordovician Silurian optima. 10 degrees Celsius, Carboniferous Permian. Cambrian explosion in warm seas, Late Ordovician glaciation, approximately 445 Ma, minus 50% species loss. From Gondwana ice sheets, Devonian warmth from low-latitude forests, Carboniferous Permian Ice Age, 330-260 Ma, vast coal swamps drawing down CO2, Permian Triassic extinction, 252 Ma from volcanism-induced warming, 10 degrees Celsius. Mesozoic, 252-66 Ma, prolonged greenhouse, no polar ice, 1825 degrees Celsius, Cretaceous peak, approximately 24-28 degrees Celsius. Triassic recovery warm, Jurassic cooler intervals with sea ice but no glaciers, Cretaceous hot greenhouse from high CO2, 1000-2000 ppm, and Pangea breakup enhancing circulation. Dinosaurs thrived in humid tropics. Cenozoic, 66 May present, cooling trend to icehouse, recent warming. 14-23 degrees Celsius, Eocene peak tilde 23 degrees C, current tilde 15 degrees C. Paleocene, Eocene thermal maximum PTM 56 Ma plus 5-8 degrees Celsius spike from methane release, ice-free poles, subtropical Arctic. Eocene, Oligocene cooling, 34 Ma, Antarctic ice sheet forms. Miocene warmth, 23-5 Ma. Pleistocene ice ages, 2.58 Ma 11.7 K. 100 K glacial cycles, temps minus 6 degrees Celsius below interglacials from low CO2 orbitals. Holocene stability until now. 21st century and Holocene Anthropocene, 11.7 K present. The Holocene interglacial, tilde 15 degrees C global mean, supported agriculture and civilization, but Industrial Revolution CO2 rise, 284-20 plus ppm, has driven +1 degree Celsius warming since 1880, with extremes like heat waves and sea level rise. Projections, +1. 4.5 degrees Celsius by 2100 under various emissions, delaying next glaciation to 5130 K. Biodiversity loss accelerates with tilde 30% species at risk. Future of Earth's climate, 22nd century end of existence. Solar luminosity increases 1% per 110 million years, driving irreversible warming despite declining CO2 from weathering. Next 100-600 million years, continued anthropogenic effects fade, CO2 drops below 50 ppm by approximately 600 Ma, killing C3 plants, forests extinct. C4 grasses persist to approximately 800 Ma 1.2 J. Habitability ends for complex life by 1 Ga as moist greenhouse evaporates oceans. Surface, 50 degrees Celsius. 3 billion years runaway greenhouse temps, 150 degrees Celsius by 2.8 Ga sterilizing surface life. Magnetic field weakens approximately 2-3 Ga stripping atmosphere. Axial tilt chaos possible 1.5-4.5 Ga causing extreme seasons. 7.6 billion years red giant phase. Sun expands, luminosity plus 67%, Earth orbits closer due to tidal drag. By approximately 4 Ga, Venus-like hothouse, 400 degrees Celsius. Full red giant expansion, tilde 7.59 Ga, engulfs Earth or ablates mantle to core, vaporizing it in approximately 200 years. Moon may form ring debris. Post-red giant to white dwarf, approximately 8 Ga onward. Sun sheds envelope as planetary nebula, becoming a approximately 0.5 solar mass carbon-oxygen white dwarf, cooling over trillions of years. If Earth survives, unlikely, it orbits a dim frozen husk at approximately 1.7 AU, tidally locked with Moon by 50 Ga, potential Moon collision approximately 65 Ga. Over 10 circumflex 15 10 circumflex 20 years gravitational encounters eject Earth or cause solar collision via radiation. Proton decay erodes remnants over 10 circumflex 36 10 circumflex 38 years, leaving radiation. No climate remains. Earth ceases as a coherent body.